Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll evaluate limit x approaches infinity and limit x approaches negative infinity for these two functions. So let's start with the first function. So the first function is f at x equals 2x plus 3 over x minus 1. Now, in order to evaluate these limits, we'll have to manipulate this function. Now, this is a rational function. And in order to evaluate the limits that approach infinity, we have to analyze the denominator of this rational function. Now, the degree of the denominator of this rational function is equal to 1. So basically the highest power on the variable in the denominator. So since the degree is 1, so we divide each term in the numerator and the denominator expression by x raised to the degree of the denominator. So in this case, the degree of the denominator is 1. So that means we divide each term in the numerator and the denominator by x raised to 1, which is also equal to just x. So in the next step, so we can rewrite this as f at x equals, so 2x over x plus 3 over x over x minus 1 over x. Now we can simplify this expression. So in the first fraction in the numerator, the x's cancel each other out. So we are left with just 2 in the numerator in the first term and then plus 3 over x in the second term. We cannot simplify this fraction. And in the denominator, in the first term, the x's will cancel each other out. So we are left with just 1 and then minus 1 over x. Now we can apply the limit. So we'll start with x approaches positive infinity. So we get limit x approaches infinity. So we have 2 plus 3 over x over 1 minus 1 over x. Now we can apply the limit separately to the numerator and the denominator. So we get limit x approaches infinity and then 2 plus 3 over x in the numerator over limit x approaches infinity in the denominator and then 1 minus 1 over x. Now we can continue on this side. Now in the next step, we can apply the limit in the numerator and the denominator. So we get 2 plus 3 over infinity over 1 minus 1 over infinity. Now infinity in the denominator makes that term equal to 0. So we get 2 plus 3 times 0 over 1 minus 0. And in the numerator, 3 times 0 is 0. So we are left with just 2 in the numerator. And the denominator is just 1. So the final answer is just 2 over 1, which is equal to just 2. So this is the result of limit x approaches positive infinity for the first function. Now we can evaluate limit x approaches negative infinity for the same function. So we can start with the setup we got by dividing each term in the numerator and the denominator by x. So it's this one. So we get limit x approaches negative infinity. So since it's the same function, we can start with this step. So 2 plus 3 over x over 1 minus 1 over x. Now we can apply the limit separately in the numerator and the denominator. So we get limit x approaches negative infinity, and then 2 plus 3 over x over now in the denominator we get limit x approaches negative infinity, and then 1 minus 1 over x. Now we can apply the limit. So in the numerator we get 2 plus 3 over negative infinity, and in the denominator we get 1 minus 1 over negative infinity. So that is also, so 1 over infinity and 1 over negative infinity are equal to 0. The 0 doesn't have a sign. So it will be 2 plus 3 times 0, and then 1. So here the negatives will become plus, but it's still a 0. So in the numerator we get 3 times 0 is 0, and 2 plus 0 is 2, and in the denominator 1 plus 0 is 1, which is equal to just 2. So we got the same result for both negative and positive infinity limits. So we are done with the first function. Now we can analyze the second function. So again we'll start the analysis the same way. So the degree of the denominator is equal to 2, because that's the highest power on the x. So we'll divide each term in the numerator and the denominator by x raised to the degree of the denominator. So it will be x squared. So we get f at x equals, so 5x squared over x squared minus 3 over x squared over, now in the denominator we do x squared over x squared plus 2 over x squared. Now we can simplify this expression. So in the numerator the x squared terms will cancel out in the first fraction. So we get 5 minus 3 over x squared over, now in the denominator the x squares will cancel out in the first fraction, and the second fraction will stay the same because we cannot reduce it. Now we can apply the limit. So limit, let's start with positive infinity. So 5 minus 3 over x squared over 1 plus 2 over x squared. Now we can distribute the limit to the numerator and the denominator. So limit x approaches positive infinity. Sorry. And then 5 minus 3 over x squared over limit x approaches infinity, and then 1 plus 2 over x squared. Now we can evaluate the limits. So we get, in the numerator, we get 5 minus 3 over infinity squared, and in the denominator we get 1 plus 2 over infinity squared. Now since infinity is in the denominator, in the two fractions in the numerator and the denominator, so they change to 0. So we get 5 minus 3 times 0 over 1 plus 2 times 0. And 3 times 0 is 0 and 2 times 0 is 0. So we are left with just 5 over 1, which is equal to 5. So this should be the final answer. Now we can evaluate the limit x approaches negative infinity. So we get limit x approaches negative infinity, and we'll use the same expression that we got after dividing each term in the numerator and the denominator by x squared. So 5 minus 3 over x squared over 1 plus 2 over x squared. Now we can distribute the limit to the numerator and the denominator. So we get limit x approaches negative infinity, and then 5 minus 3 over x squared over limit x approaches negative infinity, and in the denominator we do 1 plus 2 over x squared. Now we can apply the limit. So 5 minus 3 over negative infinity squared over 1 plus 2 over negative infinity squared. Now negative infinity square will just become positive infinity. So 5 minus 3 over infinity over 1 plus 2 over infinity. And then we can change the infinity in the denominator to just 0. So 5 minus, it becomes 3 times 0. Because 1 over infinity is equal to 0. Over 1 plus 2 times 0. Now 3 times 0 is 0, 2 times 0 is 0. So we are left with just 5 over 1, which is equal to 5. So this should be the final answer for the limit x approaches negative infinity. So these are the steps you have to keep in mind to evaluate limits that approach positive and negative infinity for rational functions. So we should identify the degree of the denominator in the rational function and then divide each term in the numerator and the denominator by x raised to the degree of the denominator. And then we just apply the limit and evaluate it. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.